Okay, so our goal today is to talk about something called the distributive property. And again, as we're taking these review notes, you should be taking anything I'm writing down, you should be writing down. Now, the distributive property, I think the best way to think about that and why it's even called the distributive property is to think about that word distribute. So when I think of the distributive property, if I think about distribute, okay, and what that means is to give out, right? Like if I were to distribute papers to a class, then I'm going to hand out papers to every student in that class. I'm distributing those papers. So when I'm thinking about the distributive property, what happens is when I have a number outside parentheses, okay, for example, okay, so I have a number that's outside parentheses that I'm going to distribute to the inside terms. Okay, so the terms that are inside the parentheses. Now this is different than the parentheses we've talked about thus far, right? So we've talked about order of operations, and in order of operations, well, we do the stuff in the parentheses first. But in this example that I wrote, we cannot add, okay? So we cannot add these terms together right now, okay, or combine them in any way. 3x and 5, those aren't like terms, and we're going to define what like terms are in a minute, but we can't add them together. So there are different ways that we approach parentheses. If we can do the things, do the operations that are inside those parentheses, then absolutely we should just go ahead and simplify. Here, we can't do these things, okay? We can't add 3x and 5 together. So one thing we can do to simplify this is instead of saying, well, I have 4 times both of these terms, is I can distribute 4 through to that parenthesis. And when I say distribute through, is we are multiplying, okay, we are multiplying that outside number through to each term in that parenthesis. Okay, so it's 4 times this parenthesis. When we distribute, it's still being multiplied through. So 4 times 3x is going to give me, let me rewrite the problem. Distributing that 4 through, 4 times 3x is going to give me 12x plus 4 times 5 is going to give me 20. Okay, so distributing through that 4 means I'm going to still be multiplying, but I'm going to multiply each term separately. Now we're going to look at several examples in a minute, and we'll talk more about what the distributive property means and how we correctly distribute a number through. But I said some words that we should probably define. So one word that we should have kind of a solid idea of, or a few examples here before we get too far, would be like terms. So I said, well, we can't add 3x and 5 because they're not like terms. Well, what makes something a like term? Like terms have the same variable, okay, and the same exponent value. So in order to be able to add or subtract things together, we need them to be like terms. So for example, if I have 4y plus 8y, okay, these are like terms. They're both y's and they're both y's to the first. So I can add those together and say, well, that's 12y. Okay, I have 4y's and I have 8y's. Oh, I have 12y's all together. I'm combining those like terms. These are like terms. If I had 4y plus 7, I can't do anything to simplify that any further. Okay, these are not like terms. And so sometimes there's nothing we can do. It's just 4y plus 7. Okay, I can't make that 11y because 7 doesn't have a y here. I also couldn't add like 4y and 10x. Well, these are different variables, so I can't simplify anything here. It's just 4y plus 10x. And what we're going to be looking at is some problems that there's several like terms to combine. So one last example here. So here's example 1, example 2, example 3. If I had, let's say, 3x squared plus 7x plus 5 subtract x squared subtract 2x plus 1. Whew. Okay, so all sorts of terms here. I can simplify this expression by combining terms that are like terms. So I have 3x squareds here, and then I have negative 1x squared there. So all together, I have 2x squared. These terms can be combined. I have 7x here, and then I have negative 2x there. Combining that, that's going to bring me to 5x. I have 7 here, take away 2. Last, I have positive 5 and positive 1. These are also like terms, just like they've always been. We've always been able to add 5 and 1 together. Okay, and that's going to give me 6. That's taken an expression that had 6 terms, and I've simplified it down to 3 terms. Okay, and especially if we were like substituting, we'd want to simplify first, because it would be a lot of work to substitute in x in all those different places versus simplifying that expression by combining like terms. We've made it easier to use that expression, for example, for simplifying. A few other words that might come up, so let me flip my page here. I'm just going to write an example. So one set of like terms that sometimes we forget about would be these terms that don't have variables, okay, or what's called our constant terms. Okay, so in this expression, 5x plus 7, 7 is my constant term. Another word that gets mentioned sometimes is coefficient. 5 is a coefficient here. Coefficient is a number in front of a variable. Okay, so I could have several coefficients in my problem. Any number that's attached to that variable is in front of that variable, which really means it's attached through multiplication. That's called our coefficient. Okay, and in order for an expression to be totally simplified, and we talked about this in the last lesson, all like terms have to be combined. And so we'll see sometimes with the distributive property that once we distribute, we can now simplify the expression even further by combining like terms. So let's go back now to the distributive property and look at a few examples. So I'm going to throw some basic examples up, and then we'll look at some funky things that can happen too. Okay, so here's two pretty basic examples of the distributive property. Again, distribute. I'm going to give that outside number to all the terms inside the parentheses. And our operation here is multiplication. Just like our coefficient, when there's nothing between the numbers, so there's no addition, subtraction, division sign notated, that's multiplication. So I'm going to be multiplying 2 through to that entire parentheses, distributing 2 to both the 3x and the negative 7. So 2 times 3x would give me 6x, 2 times negative 7 gives me negative 14. Here's my simplified expression. We want to be careful when we distribute through negatives. Okay, so negative 3 times 7 is negative 21. Negative times a negative here is going to make that plus or addition. Okay, so I have negative 21 plus 30x. Now let's look at a few other things that could happen. So one is that our distributing, it's not always that the number that we're distributing is coming first. So maybe it looks like this, negative 2x plus 5, and then 4x on the outside of my parentheses. So I can still distribute here. So there's kind of two things here that are new that we haven't quite seen yet. So one is that what's being multiplied is coming after the parentheses. I can still distribute that through. The other thing that's happening here is that I'm distributing through a variable term. So I'm going to write what happens here. So this gives me negative 2x times 4x. So instead of just multiplying, I'm going to write what that looks like. So distributing 4x to each term means I'm going to multiply each term by 4x. When I have an x times an x, well, I have two x's there, or I have x squared. So when I multiply negative 2x times 4x, I have negative 2 times 4, negative 8, and I have x times x, or x squared. And 5 times 4x is going to give me 20x. Okay, distributing through that variable term. We will also see distributing where that's not kind of the only thing that's happening in the expression. So here's an example where I have parentheses, where I can't combine what's in the parentheses, and I have some distributing that can happen out front. And I also have this other term, 6x, okay? So first thing I'm going to do is I'm going to be distributing to get rid of those parentheses, and I'm distributing a negative. Now this 6x out front is not a part of the distributing, so it's just going to kind of, what I say, come along for the ride. Okay, so 6x is still there. Nothing is changing about that term initially. Then I distribute the negative 3 through, which is going to give me negative 12x, and negative times a negative gives me a positive 15. Now that I've distributed, I can see that I have like terms here. So this 6x can be combined with this negative 12x. They're like terms, same variable, same exponent. So I can combine those to become negative 6x, and I still have this plus 15 at the end. Let's look at another example like that. So maybe I have 3 minus 7x plus 10. So this one's tricky. This 3 subtract, and then I have the parentheses starting here. I can't just like get rid of my parentheses. I got to figure out, well, why are there parentheses around this? And then the negative sign out front, what does that mean? What is distributing through? And so I call this the ninja one, okay? So this is really 3 subtract 1, 7x plus 10, or there's really this negative 1 here and not just a negative. And so I can't combine this 3 and negative 1 because of order of operations. So I can't just be like, oh, well, 3 minus 1 is 2. Okay, I'm distributing 2. Doesn't work like that because we need to multiply before we add and subtract. So when I look at this expression, I have multiplication and then I have subtraction. Well, I need to multiply first because order of operation tells me I need to multiply first. So I'm going to distribute that negative 1. The 3, similar to the 6x here, is not getting touched yet. when I distribute the -1 through, the negative's important, right? I got to keep that negative. So it's going to become -7x subtract 10. Now that 3 is a like term with this -10, and I can combine these like terms. That would give me -7 subtract 7x. Okay, there's one more thing we need to talk about. This -7 subtract 7x, I'm going to rewrite as -7x subtract 7, and I'm going to encourage you to do that as well. And you'll notice, like on our worksheet and on, I think, the checkout for distributive property, it uses the words standard form. So it says, write your answer in standard form. So standard form means I'm writing my answer from the largest exponent value to the smallest. Okay, so I'm going to transition to just looking at a couple problems that have like terms in them, and we're going to focus on this idea that when we write an answer, we want it to be in standard form, that we want it to go from the largest exponent to the smallest exponent. And our constant term is always going to be that the end of that, okay? So let me give you a few examples. Actually, I can just use this sheet here. Okay, so looking at problems 5 and 6 here that I just kind of threw up. These problems aren't involving distributive properties. This is all about cleaning up the expression and combining like terms. When I look at this expression, I have several like terms that I can combine. And I also notice that things are kind of out of order. So I have an x squared here, and then an x, and then another x squared, and I have an x cubed at the tail end. So when I think about standard form and combining like terms, I'm going to go, okay, well, my largest exponent is x cubed. So I'm going to put that out front. And I don't have any other like terms that I can combine with this -5x cubed. So I'm just going to have -5x cubed out front. The next largest exponent that I have is my x squared. So I have 1x squared here, and I have 2x squared here. So altogether I have 3x squared. Following that, I have just x's. So I have -6x and -11x. So altogether I have -17x. And then last, I have 14. So in this example, I combined like terms, but I also made sure to write things so that it's in standard form. So from largest to smallest. And I really only care about this when I have a single variable term. So on 6, you'll notice I have like an xy, and then just x's, and then just y's. Now in that case, I would like for you to write your answer kind of alphabetical. So when I'm looking at 6, what I would do, let's just kind of go through and combine things, and then I'm going to rewrite it at the end. So first term, this xy, can be combined with this xy, they're like terms. So 15 take away 4 gives me 11xy. This -9x can be combined with this positive 4x is going to give me -5x. Oh, I missed one. And this -11x is going to give me -16x altogether. Let's double check ourselves here. So -9 plus 4 is going to give me -5 minus 11. Good. So I have -16x. And then I have 5y and 19y. So I have 24y altogether. Okay, so I just went through and combined my like terms. That 6 is really ugly. Now, when I have more than one variable like this, so whether I have an xy or an rst or whatever it might be, an m and an n, I tend to rewrite it so that it's going alphabetical. So if I were to write this back out, I'd go negative 16x, and I'd put the xy in the middle, and then the 24y at the end. I'm not really too much of a stickler in terms of this sort of problem being written in this way. I'd accept this as well. But I do take points off for polynomials that aren't in standard form, okay? And we'll talk more about that the further we get into Algebra 1. For right now, if we're just combining like terms and doing the distributive property correctly, that's great, and I'm not going to be taking points off. But it's best practice to be rewriting these so that it's in standard form. And I do think a few of our worksheets during this review time say rewrite our answer in standard form. And so I'd like for you to do that. Before you kind of go on your way to do a practice set on distributive property and combining like terms, I just want to give you kind of 2 more problems that you can kind of try on your own. And so those will pop up to the right of your screen, and it should give you some feedback on how you're doing with this.